Welcome back to board preparation series for class 10th on my channel Mathify with Meenakshi. Today in this video we'll discuss topic wise important questions from the most important chapter of class 10th trigonometry. Before solving questions we must know what is trigonometry. Trigonometry is a branch of mathematics that studies the relationships between angles and sides of a triangle, particularly in right triangle. That means in a right angle triangle, if we know some sides, we can find the angles. And if we know an angle and a side, we can find the other sides. Now see, here we have a right angle triangle. Now in right angle triangle, we have three sides: perpendicular, base and hypotenuse. Now what is hypotenuse? That you know, it's the longest side opposite to right angle. Now, can I say that base is always the horizontal line and perpendicular is always the vertical line? No, that depends on frame of reference. You can say that depends on theta. The side that is adjacent to theta is your base, and the side that is opposite to theta is your perpendicular. Now, if you will take ratio of these sides, you will get the most important topic, trigonometry ratios. Now, what is trigonometry ratio? As I told you, when you divide. So, when I divide my perpendicular with hypotenuse, I will get sine. When I divide my base with hypotenuse, I will get cos. And when I divide perpendicular with base, I will get tan. There is very famous way to recall these trigonometry ratios. Pandit Badri Prasad Har Har Bhole. Now, in this way, you can learn sine theta is P by H, cos theta is B by H, and tan theta is P by B. Now, what about other three trigonometry ratio? That is cosec, sec, and cot. That is the reciprocal of these three. You can say what is cosec. If you want to see cosec, you will say h by p. Sec h by b and cot b by p. Now we understand trigonometry ratios. The next important step is proving identities. You already know the most important identity, that is sine square theta plus cos square theta is equal to 1. But you should know the proof of these identities too. We have three identities here: sine square plus cos square theta is equal to 1. Then the second one is tan square theta plus 1 is equal to secant square theta. And third, 1 plus cot square theta is equal to cosec square theta. So we'll see proof one by one. First, how will prove sine square theta plus cos square theta is equal to 1? With the help of Pythagoras theorem. So you will take one right angle triangle. As I told you, if you will mark this as theta, then your base is BC and your perpendicular is AB, and hypotenuse is fixed, that is AC. Now, according to Pythagoras theorem, we know that h square is equal to p square plus b square. Now divide both the sides by h square. H square by h square become 1. And what is p square by h square? You know that's sine square theta. And what is b square by h square? That is cos square theta. So here we proved our first identity, that is sine square plus cos square theta is equal to 1. Now if you have to prove second identity, that is tan square theta plus 1 is equal to secant square theta. For that, first you will prove your first identity. Then once you reach to this step, you will simply divide both the sides by cos square theta. Now just see, sine square theta by cos square theta, that is tan square theta. Cos square theta by cos square theta, that is 1. And 1 by cos square theta is secant square theta. So we have proved our second identity. Let's prove third identity. For third identity, again you will prove first identity first, this one. Now you will divide both the sides by sine square theta. That means sine square theta by sine square theta plus cos square theta by sine square theta equal to 1 by sine square theta. Now sine square theta will become 1. Cos square theta by sine square theta will give you cot square theta, and 1 over sine square theta will give you cosec square theta. So you have to see proof of these three identities as it can come in your exam. Now let's move to first topic, trigonometric ratios. As we have already discussed trigonometric ratios, sine theta, cos theta, tan theta, cosec theta, sec theta and cot theta. Let's write these ratios in terms of perpendicular and base. You know your adjacent side means base and opposite side means perpendicular. So sine theta is P by H, cos theta is B by H, tan theta is P by B, and these are the reciprocals. So H by P, H by B, and B by P. Okay. Now let's move to question number 1. In question number 1, it's given sine A is 3 by 5. So you have to take this angle other than 90. So I'm taking A here and 90 as B. Now it's given that your sine A is 3 by 5. This is perpendicular and this is hypotenuse. As you know, sine is P by H. Now perpendicular is given. What is perpendicular here? Perpendicular is 3 and hypotenuse is 5. Can you tell me something about base? Yes, use Pythagoras theorem. That is square root of h square minus p square. What is 5 square minus 3 square? 25 minus 9, that is root 16. You can say 4. So now you know that your b is 4 here. Okay, using Pythagoras, we have found the third side. Let's see now. Tan A. What is tan A? Just put the values. Tan A is P by B. What is our P here? P is 3 and B 4 plus sec A. What is your sec A? Just see here, sec A is H by B. Now H by B. You can simply take the LCM, that is 4, and 3 plus 5 is 8. 8 by 4 square. And that is nothing but 2 square. You can say answer is 4. Let's move to second question. Question number 2. Sine theta is equal to A by B. Then find cos theta. So again you will make a triangle. It's given sine theta. So I'm taking theta here and 90 degree here. So you can say this is your perpendicular, this is your hypotenuse, and this is your base. Now sine theta is A by B. So your P is A and your H is B. What is your cos theta? You know your cos theta? Cos theta means that's your B by H. Now what is my B? My B, you have to find base. What is your base? Base is square root of h square minus p square. Let's find that. Square root of h is b. B square minus perpendicular square, that is a square. You can write square root of b square minus a square. And your h is b. So this is your answer. This is your answer. But here we have one more way. Because you know the identity sine square theta plus cos square theta is 1. So I'm telling you method 2 too. Method 2. We know sine square theta plus cos square theta is 1. So we know that from here we can say what is the value of cos theta. You can say first you will find the value of cos square theta, that is 1 minus sine square theta. And if you want to find the value of cos theta, just remove square here and there you can write square root. That is 1 minus square root of sine square theta. And you know the value of sine theta? That is a by b. You can write 1 by a square by b square. That you can write b square minus a square by b square. So if you will take outside the denominator of square root, what you will get? You will get by b. So you have two ways, method 1, method 2. Either you can use trigonometric ratios or you can use trigonometry identity for this particular question. Let's move to third question. In third question, it's given that tan theta is a by b. Find a sine theta minus b cos theta upon a sine theta plus b cos theta. Here again, there is one way that you will find the value of sine theta and cos theta using Pythagoras, and then you can put the values using trigonometry ratios. But here there is one more way. I will tell you that method because trigonometry ratio method I've already explained in first two questions. If you realize carefully, you need tan. How I can get tan? Using sine and cos, simply divide your numerator and denominator by cos. So I will divide numerator by cos. What I will get? I will write that for you. A sine theta minus b cos theta by cos theta, and then a sine theta plus b cos theta by cos theta. We have to divide by same. So we have divided by cos theta. Now just break this. What is a sine theta by cos theta? That is a tan theta because sine by cos is tan. Minus what is b cos theta by cos theta? Cos theta you can get. So we are just left with b. Here again a sine theta by cos theta, that is a tan theta, and plus b cos theta by cos theta plus b. Now you know the value of tan theta, just put that. It's a by b. You can write a square by b minus b over a square by b plus b. Just take the LCM here. What you will get? Cross multiplication, that is a square minus b square. And here again take the LCM, that is b. Again do cross multiplication for numerator. A square plus b square. You can cut b and b. So your final answer is a square minus b square by a square plus b square. So in this question also you have two options. Either you can directly divide your numerator and denominator by cos theta, or you can use trigonometry ratio and find the values of sine theta and cos theta. Now let's move to second topic, values of trigonometric ratios. For this topic you should know the values of trigonometric ratios, but in case you don't know, at least learn values of sine theta. Once you know the values of sine theta, you can find the values of other ratios. How? For cos theta, just take the values in reverse order. You can see 1 root 3 by 2, 1 by root 2, half and 0. For tan, you have to simply divide sine and cos. You will get the values of tan. For cosec, it's the reciprocal of sine. For sec, it's the reciprocal of cos. And for tan, it's the reciprocal of tan. So in case you know the values of sine theta, you can find the values of other trigonometric ratios too. Now let's see question number 1. Which one is true? Now they're comparing ratios. So I'm telling you one note here. Just note it down that your cos theta is always a decreasing function from 0 to 90 degree. As you can see your values too, it's decreasing. Sine theta and tan theta both are increasing function. Sine theta and tan theta, they will increase once the value of theta will increase till 90 degree. Okay. Now, what about if we'll compare, like here we are comparing sine and cos. For that, how we can check? So for this, you should know that from 0 to 45 degree, your cos is more as compared to sine. But after 45, that means from 45 to 90 degree, your sine is more as compared to cos. I didn't wrote equal to sine for 45 here because at 45 they both are equal. Now let's compare. As I told you, cos 30 and cos 20, which one is more? As you know, it's a decreasing function. For 20 it's more, so that is wrong. Sine 30, sine 20. Yes, it's correct because sine is an increasing function. When theta is more, it's more. For tan 30 and tan 20, you should know that tan 30 is more. So that is also wrong. And cos 30 and sine 20, as I told you, for less than 45, cos is more. So that is also wrong. So correct option is B option. Let's move to question number 2. In question number 2, it's given that A is 30 degree and you have to verify this. So let's solve LHS first. What is sine 2A? That means sine 2 into 30, sine 60 degree. Now sine 60 degree, you can check here. It's root 3 by 2. Now we have to solve RHS because we have to verify that they're equal. For RHS, it's given 2 tan A. That means 2 tan 30 degree divided by 1 plus tan square 30 degree. So let's solve this. Now 2 tan 30 degree, you can see here tan 30 degree is 1 by root 3. 2 into 1 by root 3 divided by 1 plus square of 1 by root 3. That means 2 by root 3 upon 1 plus 1 by 3. You will take the LCM here. So 2 by root 3. Here you will get 4 by 3. Yes. Now we can cut here 1 and 2. And if you will cut this, you'll get 1 and root 3. So what's your answer? It's 1 by 2 root 3. So if you will reciprocate it, you will get root 3 by 2. Yes, both are equal. So we have verified that LHS is equal to RHS. Now let's move to third question. In third question, we have to find the value of root 2 cos 45 degree plus 2 root 3 cos 30 degree. So let's put the values here. Root 2 into cos 45. What is cos 45? It's 1 by root 2. Plus 2 root 3 into cos 30 degree. What is cos 30 degree? It's root 3 by 2. Now quickly solve this. Root 2 you can cut and 2 you can cut. This is 1 plus root 3 into 3 is 3. 1 plus 3. The answer is 4. C option. Let's move to question number 4. In question number 4, it's given if cos A plus B is 0. Now when cos is 0, at 90 degree, you can say cos 90 degree. This means you can say that your A plus B is 90 degree. Just compare these two. Now, what is cos A plus B by 2? You know that if A plus B is 90, that means 90 by 2, and that means is cos 45. And what is your cos 45? You can see here it's 1 by root 2. So correct answer is A option. Let's move to question number 5. In question number 5, it's written 2 bracket cos square 45 degree, that is half 1 by root 2 square, plus root 3 square is 3, minus 6 bracket sine square 45 degree, again it's half, tan square 60 degree is 3, divided by tan 30 1 by root 3, cot 60 1 by root 3. Solve this, you will get 2 into 7 by 2 minus 6 into minus 5 by 2. You can cut this, and in denominator you can write 2 by root 3. So in numerator you are left with 7 plus 15, and in denominator it's 2 by root 3. When you will move to numerator, it will become root 3 by 2. Now what is 7 plus 15? It's 22 into root 3 by 2. If you will cut, you are left with 11 root 3. So answer is 11 root 3. Let's move to question number 6. In question number 6, it's given sin A is equal to cos A. Sin A is equal to cos A. Whenever it's given, just think when they are equal at 45 degree. So just directly put A as 45 degree. Yes. Even you can do one more thing. You can divide both the sides by cos and you will get tan A is 1, and that means A is 45 degree. Now just put the value of A as tan 45 here. 2 into tan square 45 degree. We know tan 45 degree is 1. That means 2 into 1 plus sine square 45 degree. Again, it's 1 by root 2 square. That means half minus 1. Now, this is 2. 2 minus 1 is 1. 1 plus half, that is 3 by 2. So the final answer is 3 by 2. Let's move to next question. Question number 7. Again, it's the same question. When sine theta is equal to cos theta, that means your theta is 45 degree. Now, sine 6 theta, that means sine 45, that means 1 by root 2 raised to the power 6. Again, cos 45 is same, 1 by root 2 raised to the power 6. Now, what is, if you will multiply root 2 6 times, root 2 into root 2 is 2. 2 into 2 into 2, 8. So 1 by 8 plus 1 by 8. That means 2 by 8, and that means 1 by 4. So the answer is 1 by 4. Let's move to question number 8. Again, sine A plus 2B. Just write this in terms of sine. You can see the value here. 60 degree. That means you can write that your A plus 2B is 60 degree. Now what about this value in terms of cos? Half. That is again cos 60 degree. If you will compare, you will get A plus B is 60 degree. Now we can simply solve this using elimination. So I'm just changing the sign here, minus, minus, minus. So let's solve this. A minus A is 0. Now 2A minus B, that means B. And 60 minus 60 is 0. That means my B is 0. So what about your A? If you put the value of B in any one equation, you will get your A as 60 degree. So answer is A is 60 and B is 0 degree. Now let's move to question number 9. So first you will transpose cos theta to that side. Becomes root 3 sine theta is equal to cos theta. Now just simply divide this whole equation by cos theta. What you will get? Root 3 sine theta by cos theta is equal to cos theta by cos theta. Why we are doing that? Because we know that this becomes 1 and here it's tan theta. So we can write root 3 tan theta is equal to 1. Now just transpose root 3 to that side. It becomes tan theta is 1 by root 3. And now just check. When your tan theta is 1 by root 3, it's at 30 degree. You can write this as tan 30 degree. That means your theta is 30 degree. That's your answer. Let's move to next question. 1 plus cos A into 1 minus cos A is equal to 3 by 4. It's very easy. You just see the identity. A plus B into A minus B. What's the identity here? It's A square minus B square. That means 1 square minus cos square A. This is given, it's 3 by 4. Now, what is 1 minus cos square A? If you know the identities, that's cos square A plus sine square A is 1. That means 1 minus cos square A is sine square A. Now, sine square A is 3 by 4. What is your sine A then? Just take the square root both the sides. It's root 3 by 4. You can write root 3. Root 4 is 2. Now you know your sine A. Now just check when your sine is root 3 by 2. Just see here table 60 degree. That means your A is 60 degree. You can write this as sine 60 degree. So that means your A is 60 degree. Once you know your A, just find the value of tan 60 because they are asking tan A. What is tan 60? It's root 3. So final answer is root 3. Now let's move to question number 11. It's given angles of triangle ABC are in the ratio 1 is to 1 is to 2. Now you know that your greatest angle in right triangle is 90 degree. So I'm taking that as 2x and other 2 as x in x. Now you know that 2x is 90 degree. That means your x is 45 degree. So your A and B are 45, 45 and your C is 90 degree. So let's put the value here now. Cos 45 into cos 45 because A and B both are 45 minus sine 45 sine 45. Now you know that cos 45 and sine 45 are equal. That means this is also 1 by root 2 into 1 by root 2, that is half. Here also 1 by root 2 into 1 by root 2, that is half. So it becomes 0. So answer is C option. Let's move to 12th question. In 12th question it's given that 1 plus sine theta upon 1 minus sine theta is equal to 3. You have to find theta. Let's do cross multiplication. I will write 1 plus sine theta is equal to 3 minus 3 sine theta. Now transpose 3 sine theta to this side and 1 to right side. So we get 3 sine theta plus sine theta, that is 4 sine theta is equal to 3 minus 1, that is 2. That means your sine theta is 2 by 4. And when you will cut 2 by 4, you will get 1 by 2. Now when is your sine theta half? At 30 degree. That means your theta is 30 degree. Now let's move to third topic, trigonometric identities and algebraic identities. So here I have attached these two pics just for you so that you can recall algebraic identities as well as trigonometric identities. Now see question number 1. Cos square theta plus 1 by 1 plus cot square theta. If you know what is 1 plus cot square theta, you can see here it's cosec square theta. So you can write cos square theta plus 1 by cosec square theta. Now just think which trigonometric ratio is the reciprocal of cosec. It's sine. So cos square theta plus sine square theta. Now what is cos square theta plus sine square theta? It's 1. So answer is B option. Let's move to second question. In second question, it's given secant theta minus tan theta is m, and they're asking for the value of sec theta plus tan theta. Just think which trigonometric identity we can use related to secant and tan. We can use that secant square theta minus tan square theta is 1. Now just use identity a square minus b square here. So you can write sec theta plus tan theta into sec theta minus tan theta is 1. Now you know the value of sec theta minus tan theta, that's its m. So if you will transpose this value here, it will come in denominator. So you can write that sec theta plus tan theta is 1 by sec theta minus tan theta, and that is 1 by m. So final answer is B option. From this you can just learn this thing, that if your value of sec theta minus tan theta is given like k, then sec theta plus tan theta will be 1 by k, and vice versa. If sec theta plus tan theta is k, then sec theta minus tan theta is 1 by k. And similarly, it holds for cosec and cot. Like cosec theta minus cot theta is m, then cosec theta plus cot theta is 1 by m. Using this identity a square minus b square. Okay, so learn this. In MCQ, you can directly put a tick mark that they are reciprocal of each other. Let's move to question number 3. It's given cosec theta plus cot theta is equal to p. As I told you in question number 2 only. So whenever it's given cosec theta plus cot theta, you can always find cosec theta minus cot theta. That is a reciprocal of this value. That's 1 by p. So you will write step in exam like cosec square theta minus cot square theta is equal to 1. Then use third identity and then write this step. Now I will solve these two equations. You can cut cot and cot. What is cosec plus cosec? It's 2 cosec theta is equal to p plus 1 by p. Now let's find the value of cosec theta from here. So you will write cosec theta is equal to half of p plus 1 by p. That means half of p square plus 1 by p. We have to find the value of cos theta. Is there any direct relation between cosec and cos? No. So what we can do, we know that cos is related to sine. Yes. And sine is related to cosec. So we'll find the value of sine. Now what is sine theta? It is 1 by cosec theta. Yes, reciprocal. So just take the reciprocal of this. You will get 2p by p square plus 1. Now, what is cos theta in terms of sine theta now? Cos theta is, as you know, cos square theta is 1 minus sine square theta. So my cos theta is, take the square root both the side. You will get square root of 1 minus sine square theta. Yes. And that is, cos theta is 1 minus 2p by p square plus 1 whole square. Now just take the LCM. You will write p square plus 1 whole square minus 2p square is equal to, is by p square plus 1 whole square. Yes. Now just solve this. It will give you p4, just use identity a plus b square, p4 plus 1 plus 2p square, and here it's 4p square by p square plus 1 square. Now, if you will solve these two, what you will get? You will get p4 plus 1 minus 2p square. And in denominator, you can write, because square and square root will get cancelled. So you can write, without square root, you can write p square plus 1. Yes, it's an identity of p square minus 1 whole square by p square plus 1. So square and square root will get cancelled out. So your final answer is p square minus 1 by p square plus 1. So you have proved this result. Yes, hence proved. Let's move to next question. Question number 5. Again, it's given 5x is sec theta and 5 by x is tan theta. Whenever sec theta and tan theta are involved and square is there, just use the identity that secant square theta minus tan square theta is 1. Just put the value here. 5x whole square minus 5 by x whole square is 1. That is 25x square minus 25 by x square is 1. You can take 25 common and you are left with x square minus 1 by x square is equal to 1. But here we have 25 and we need 5. So let's divide both the sides by 5. What you will get? Here you will get 5. So you can write the answer of 5 x square minus 1 by x square is 1 by 5. Yes. Now let's move to question number 5. Question number 5. It's given k plus 1 is equal to secant square theta 1 plus sine theta 1 minus sine theta. A plus b, a minus b. What is that? A square minus b square. 1 square is 1, so I'm writing directly. Now what is 1 minus sine square theta? We can directly write cos square theta. Okay, so we can replace this by directly by cos square theta. So let's write this now. K plus 1 is equal to secant square theta into cos square theta. And did you realize something? Yes, secant cos are reciprocal of each other. You can write k plus 1 is equal to sec square theta into 1 by sec square theta. You can cut this. That means k plus 1 is equal to 1. Just transpose 1 to that side. K is equal to 1 minus 1. That is your k is 0. C option. Let's move to next question. Just see here. Here, you know that if we'll break, we can write this as a square plus b square or a cube plus b cube because 6 is divisible by both 2 and 3. But you know that we have an identity for square, sine square plus cos square. We don't have any identity for sine cube plus cos cube. So what we'll do, I will break like this. Sine square a cube plus cos square a cube. Now we know a cube plus b cube. Yes, we know a cube plus b cube can be written as one thing. If you will see the identities, it can be written as a plus b into a square plus b square because it's here plus you can write minus ab. But if you solve like this, just see what you will get. You will get here sine square plus cos square. That is 1. But here you will get sine raised to the power 4, cos raised to the power 4, minus sine square cos square. How you will solve this? Just think, can we write something so that we'll get 3 directly? Just think. Yes, we know one more thing that a cube plus b cube can also be written as a plus b whole cube minus 3ab into a plus b. That you learn in your polynomials chapter, alpha cube plus beta cube. So you can use this here. Why? Because you know that we need 3. So that's why we will not use this and we will use this. Now I will use this. I have to just explain this why I'm using this. Now let's use directly. Again I'm writing this is as sine square a cube plus cos square a cube is equal to sine square a plus cos square a cube minus 3ab, that means minus 3 sine square a cos square a into a plus b, that is sine square a plus cos square a. I will write that identity again for you. A cube plus b cube is equal to a plus b whole cube minus 3ab into a plus b. So whenever you know that we need 3 in RHS, just use this identity. Okay. Now, what is sine square plus cos square? This is 1 cube, that is 1 only, minus 3 sine square a cos square a into again 1. That is, we can leave that. So we have proved RHS just in one step. Let's move to next question. If cos A is 3 by 5, find the value of 9 plus 9 tan square A. Again, just think tan square A. Whenever you have squares now, just think for identities first. Yes, you can take 9 common. What we are left with? 1 plus tan square A. Now what is 1 plus tan square A? That is secant square A. Now, secant is reciprocal of cos 1 by cos square A. You know the value of cos? Cos is 3 by 5. That means cos square A is 9 by 25. Just take the square. So here you can write 25 by 9 because it's a reciprocal of cos. So 25 by 9. You can cut 9 and 9. You're left with 25. It's direct. So you know where we have to use the identity. Although here you can also use trigonometric ratio, but if you will use that, it will consume your time. So use identity. Let's move to question number 8. In question number 8, it's given that your sine theta plus sine square theta is 1. Again, you have square. Just move to that side so that it becomes identity. Sine theta is equal to 1 minus sine square theta. Now, what is 1 minus sine square theta? See here. It's cos square theta. That means your sine theta is cos square theta. Just replace this. You can write sine theta is cos square theta. Here also we have square. Can we make any identity? Yes. If cos 4 theta, how I can replace cos 4 theta? Cos 4 theta is, if you will take square both the sides here. If you will take square both the sides, what you will get? Cos 4 theta is sine square theta. That means you can write cos square theta as it is plus value of cos 4 theta is sine square theta. And what is that? It's identity. That's 1. So whenever you see square, you have to wait for identity first. If you can't use identity, then you will think for something else. Let's move to question number 9 now. Question 9 is direct. It says which one is not equal to unity. What is the meaning of unity? 1. Which one is not equal to 1? Just think. Sine square plus cos square. It's equal to 1. This is true. Now, cot square minus cosec square theta. No, cosec square is more. So it should be cosec square minus cot square. If you will write cot square minus cos square, this is equal to minus 1, not 1. So this is the correct answer, not equal to 1. Because you know tan and cot, they are reciprocal. It will give you 1. True. And secant is more as compared to tan square. It will also give you 1. So you should know this thing. Secant square minus tan square is 1 and cosec square minus cot square is 1. If they will reverse the order, you will get minus 1. Let's move to question number 10. Again, use identities. 1 minus sine square theta. What is 1 minus sine square theta? That is cos square theta. But it's under square root. You can write cos theta. Into secant square theta minus 1. That is tan square theta. But again, it's under root. You can write tan theta. Into 1 plus cot square theta. That is cosec square theta. That is cosec square theta. But again, under root. You can write cosec theta. Now, what is cos? It is right in cos only. Tan is sine by cos. And we are converting everything in sine cos. And cosec is 1 by sine because it's a reciprocal of sine. Now just cut this, cut this. You are left with 1. So answer is 1. Let's move to question number 11. In question number 11, it's written sine 8a minus cos 8a. So first we'll make them whole square. We'll write sine 4a square minus cos 4a square. Use a square minus b square identity. That is, one time you will write in between plus and one time you will write in between minus. Okay, till here it's clear. Now, again, if you realize that it sine square square a. Yes, we can further break it this plus cos square square a. Similarly here, sine square square a minus cos square square a. Now, again, sine square a plus cos square a. What you can do? Here you will use that identity. Alpha square plus beta square is alpha plus beta whole square minus 2 alpha beta. Why we are using this? Because then sine square plus cos square will be 1. So let's use that. Alpha, that is sine square a plus cos square A whole square minus 2 sine square cos square. This we have just solved for first bracket. Yes. Now let's solve second bracket. For second bracket, what we'll get? I'm solving this bracket now. Sine square A minus cos square A. That you know, it's identity again. A square minus B square. You can write sine square A plus cos square A into sine square A minus cos square A. Done till here? Now, what is sine square plus cos square? It's 1. 1 square is 1. So just write 1 minus 2 sine square A cos square A. Yes? Bracket close. Second bracket is again sine square plus cos square is 1. And third bracket is sine square A minus cos square A. Did we get our answer? See here. 1 minus 2 sine square A cos square A. This is here 1 minus 2 sine square A cos square A. But what about first bracket? It is 2 sine square A minus 1. That means we doesn't need cos. We doesn't need this cos. Just do something with this cos. So what we'll do? Just replace this with the help of this identity. You know that cos square A is 1 minus sine square A. So just replace this. You will write this bracket as it is because we need this. If it's not a MCQ, you can leave here only. But if it's a MCQ, so we have to see one of the answers. So now I will replace my this with, because cos square is 1 minus sine square, but in front of this it's minus sign. Just change the sign of both. You will write minus 1 plus sine square. Okay. Now what is sine square plus sine square? It's 2 sine square minus 1. So B option is correct. Okay, so whenever we have the power 8, you have to break in 2 times 4, then 2. Let's move to question number 12. Prove that sine A plus cosec A whole square plus cos A plus sec A whole square is equal to 7 plus tan square A plus cot square A. You can see whenever we have a whole square, let's use this because we have an identity for sine square and cosec square. So let's take the A plus B whole square. That is sine square A plus cosec square A plus 2 sine A cosec A. Okay, it's cosec. Now just open the next bracket too, plus cos square A plus sec square A plus 2 cos A sec A. This we are solving LHS. Solving LHS. Now just see, we need number here. That means we can use these identities. Just see, sine square plus cos square. It will give you 1. Yes. Can we do something else? Just think cosec square. Here we have cosec square. And here we don't need cosec square. So can we do something with cosec square? Yes. We need cot and tan. So just break this as 1 plus cot square A. Similarly here, we don't need secant. So let's break secant by 1 plus tan square A. So now we have 2 more ones. 1, 1. And what we're left with? Cot square A, tan square A, plus 2 sin A cosec A and 2 cos A sec A. Now, what is sine into cosec? Did you realize something? Sine and cosec, they are reciprocal of each other. So they will cut. So you're just left with 2. Similarly, cos A and secant A, again they are reciprocal of each other. You will get, that's 1, 2 into 1 is 2. So 2 plus 2, that's 4. Now, it's 1 plus 1 plus 1 plus 4, that is 7. 7 plus cot square A plus tan square A. So that's your RHS. So always focus what we need in RHS, because if you don't need something, so you have to replace that. Like here we don't need cosec square and secant square. That's why we convert that to tan and cot square. Let's move to next question. Find the value of sine A minus 2 sine cube A divided by 2 cos cube A minus cos A. Again, it's a question of NCRT. Just think what I can do in numerator. I can take something common. I can take sine A common. That is 1 minus 2 sine square A. Now in denominator, you can take common cos A. You will get 2 cos square A minus 1. So what we'll do, we'll just convert one thing in terms of other. So I will write sine A. Now 1 minus 2 sine square A. Just replace your sine square A with the help of this 1 minus cos square A. Get 1 minus cos square A. Because we have to cut this, then only we can solve. And in denominator, just write cos A by 2 cos square A minus 1. Okay, you can write A here. Now what I will do now, sine A, just see carefully, just multiply 2 with both. You will get 1 minus 2, minus minus is positive, plus cos square A, 2 cos square A by cos A into 2 cos square A minus 1. Now, did you realize something? What is this in numerator? 1 and minus, it's minus 1 only. So minus 1 cos square A, this you can cancel. You're just left with sine A by cos A. And what is that? It's tan A. Done? That's it. So whenever you feel that we have sine square and cos square, just replace them. We have the relation for sine square and cos square. Now let's move to 14th question. This is also important. It can come for one marker, like express sine theta in terms of cos theta, or cos theta in terms of sine theta. But here they ask all. So that's why it's important. I'm telling you all so that if it will come for one marker, you know how we can convert. First thing we see that what is directly related with sine theta in terms of trigonometry ratio or trigonometric identities. We know that cosec theta is directly related because it's a reciprocal. So cosec theta is 1 by sine theta. We are done with cosec. Now, is there any other trigonometry ratio that depends on sine? Yes, cos. You know here cosec square theta is 1 minus sine square theta. So if we'll take square root, what you'll get? You will get that cos theta is square root of 1 minus sine square theta. So we have written two trigonometric ratio in terms of sine. Now, just think, if you know cosec, can you say something about other trigonometric ratio? Who is related to cosec? Yes, cot. We know that cot theta is cosec square root of cosec square theta minus 1. Yes, you can use that. You can write cosec square, that is 1 by sine square theta minus 1. That is 1 minus sine square theta by sine square theta. So you can just take that outside and you can write sine theta. Now you know cot theta also. Now if you know cot theta, you can write tan theta because tan theta is 1 by cot theta. Tan theta is 1 by cot theta. Just do the reciprocal. You will get sine theta by 1 minus sine square theta. When they will ask, write in terms of any trigonometry ratio, no need to rationalize. You can leave it here also. Now, what we are left with? We have left with sec. Secant. Secant is related to what? Just think. Secant is related to cos. So if you know cos, you can write secant is reciprocal of cos. That is 1 by 1 minus sine square theta. That's it. So you have to always think about the reciprocal, like cosec and sine, cos and sec, tan and cot, and the identities. Then using these two things, you can find all the trigonometric ratio in terms of another trigonometric ratio. Let's move to next topic. Direct substitution of values of variable. So this is very easy. If you know variable is equal to something, direct, like variable is equal to something, then if something you have to prove, just put the value of variable, like m square minus n square. What is LHS? M square minus n square. So just put the direct value m square to take the square of this, both the sides. I'm writing directly tan square theta plus sine square theta plus 2ab, that is plus 2 tan theta sine theta. Similarly, now you will write minus n square. So put a bracket first. Take the square both the sides to find n square. So I'm using different color so that you will not get confused. Again, tan square theta plus sine square theta minus 2 tan theta sine theta. Now just open this bracket. Tan square theta plus sine square theta plus 2 tan theta sine theta. When we have a minus outside, you have to change the sign of all the terms. So it becomes minus tan square theta minus sine square theta and positive 2 tan theta sine theta. Yes. Now just see, can we cut something? Yes, tan and tan, sine and sine. 2 tan theta sine theta is 2 tan theta sine theta. It becomes 4 tan theta sine theta. Now we have to stop here. This is the LHS. Now let's solve RHS. RHS. What is your RHS? RHS is 4 root mn. That means 4 under root. You can write mn in. M is tan theta plus sine theta into tan theta minus sine theta. Okay. Now what is a plus b into a minus b? That is a square minus b square. Tan square theta minus sine square theta. Now just think, 4 they are already equal. Basically we have to prove that tan theta sine theta is equal to tan square theta minus sine square theta. Here we have a multiply sign, here we have a minus sign. How we can convert minus sign to multiply? By factorization. So let's take the factorization here. First you will convert your tan square theta in sine cos. You will write sine square theta by cos square theta. And here you will write minus sine square theta. Now we'll take sine theta common. And sine square theta will take common, but because it's a square root, so out we'll take it outside and become sine theta. Now we are left with 1 by cos square theta minus 1. Now 4 sine theta. So just solve this. 1 minus cos square theta by cos theta square theta. Now what is 1 minus cos square theta? It is sine theta. What is square root of cos square theta? It's cos theta. Sine theta over cos theta, that becomes tan theta. So we have proved that our LHS and RHS are equal. Yes. So that's it. Let's move to question number 2. In question number 2, again we have to put the values directly. X is given, Y is given. So first LHS. B square, I'm putting the values directly. X square means take the square both the sides. Becomes A square cos square theta. Now plus A square into Y square. Again for Y square, just put that square both the sides. So we'll get B square sine square theta. Now take common A square B square. You are left with cos square theta plus sine square theta. And what is cos square theta plus sine square theta? It's 1. So A square B square into 1, that is A square B square. So done with this question 2. Now let's move to question number 3. Again, we'll just put the values of x, y, z directly. So what is our LHS? X square plus y square plus z square. First, let's find the value of x square. So take square both the sides. What you will get? R square sine square A cos square C. Now what's the value of y square? Just take square both the sides. You will get R square sine square A sine square C. For z square, again take square both the sides. It's R square cos square A. Now, you will take R square common. What you are left with? Sine square A cos square C plus sine square A sine square C plus cos square A. Now, can we take something common for first two steps? Just see carefully. Yes, you can take sine square A common. So you're left with cos square c plus sine square c and cos square a outside the bracket. Now, what is this cos square c plus sine square c? That is 1. So you can write r square sine square a into 1. That is, you can write sine square a only. But I'm showing you the step plus cos square a. Now what is sine square a plus cos square a? It's 1 using identity. So we have proved that this is equal to RHS. Hence proved. Now let's move to fourth question. Value of x is given to you and value of y is given to you. You have to prove that x square minus y square is equal to a square minus b square. Again, you will put the value of x and y directly. Just take the square of this. You will get a square secant square theta plus b square tan square theta plus 2ab sec theta tan theta. Yes, I've just used identity a square plus b square plus 2ab. Now we have a minus sign in between. So I'm just changing the signs directly, because if you will take the square, you will get a square tan square theta plus b square secant square theta plus 2ab tan theta sec theta. Because it's minus here, so I'm changing the sign for all the three terms. So I will get a square tan square theta. In exam, you have to write the steps. Minus b square secant square theta minus 2ab secant theta tan theta. Yes, now we can cut this and this. What we are left with here, a square is common. You can take from sec square theta minus tan square theta. And similarly, you can take b square common from these two. So b square positive b square in bracket you can write tan square theta minus secant square theta. Now, what is secant square theta minus tan square theta? That is 1 only. And what is tan square theta minus secant square theta? As I told you, secant square theta should come first. If not, then you will change the sign. It's positive, you will write minus, because tan square theta minus secant square theta is minus 1. That is a square minus b square. That's it. We have proved this is equal to RHS. Now let's move to next topic. Solving by taking LCM or rationalization. So you have to always see your denominators carefully. If it's like this, a minus b and a plus b, that means the numbers are same, just the sign is different, then always take LCM. That means you can take the product. And what is product of a minus b and a plus b? Just think identity, it's a square minus b square. That means secant square a minus 1. For numerator, just do the cross multiplication. That is secant a plus 1 plus secant a minus 1. Can we cut something here? We can cut 1 and minus 1. 2 secant a is equal to secant square a minus 1. What is secant square a minus 1? That is tan square a. Because here we need the answer in cosec and cot. So just convert it to sine cos. Then we can convert to cosec cot. So 2 by cos a here. And what is tan square a? That is sine square a by cos square a. Yes. One cos you can cut. You are left with, just take the reciprocal of this. You are left with 2 into cos a by sine square a. Now, what is sine square a by cos a? You can write it like this: 2 by sine a. Just break sine a and cos a by sine a. Now, cos a by sine a is cot a, and 1 by sine a is cosec a. And just write 2 as it is. 1 by sine a, it's cosec, and cos by sine, it's cot. Hence proved equal to RHS. Let's move to second question. Again, you have seen that it's root 1 plus cos a. So you can rationalize this. Whenever we have a root in denominator, we can rationalize. So what we'll do, we'll simply multiply. Rationalization means you have to change the sign of in between. If it's plus in denominator, you will multiply by minus. You will multiply by 1 minus cos a 1 minus cos A. It's in root, so you will write root. Now, just multiply this. What is 1 minus root 1 minus cos A? Root 1 minus cos A. That is root 1 minus cos A whole square. So you can cut root and square. You can write 1 minus cos A. And in denominator, you can write root 1 plus cos A 1 minus cos A. That is A square minus B square. Now, 1 minus cos square A is sine square A. But it's a square root, so you will write directly sine A. Now just break this. 1 by sine A minus cos A by sine A. 1 by sine A is cosec A and cos A by sine A is cot A. And that is equal to RHS. Let's move to third question. In third question, again, if you'll see carefully, here the sign is different. So again, we'll take LCM. In LCM, A plus B, A minus B, that is sine square A minus cos square A. And for numerator, you will do cross multiplication. That is A plus B whole square. You can write sine square A plus cos square A plus 2 sine A cos A. And similarly here, plus A square plus B square minus 2AB. That is minus 2 sine A cos A. Clear? Now, what is sine square A plus cos square A? 1. And here also it's 1. Just write 1 plus 2 sine A cos A plus 1 minus 2 sine A cos A. In denominator, sine square A minus cos square A. Now, can we cut something in numerator? Yes. What is 1 plus 1? It's 2. In numerator, we want 2 only. But in denominator, we don't want cos. So just replace cos with sine. So how I can replace cos with sine? You can write it's 1 minus sine square A. Now write sine square A. Just see this minus outside. It will change the sign of both the terms in bracket. So minus 1 plus sine square A. And that will give you sine square A plus sine square A is 2 sine square A minus 1 equal to RHS. Let's move to question number 4. In question number 4, again, here we have cosec theta minus cot theta and here cosec theta plus cot theta. But the problem is that one is on left side and one is on right side. What we can do, just transpose this. Just move this to this side and sine theta to this side. So now our LHS becomes 1 by cosec theta minus cot theta plus 1 by cosec theta plus cot theta. Now it's the same and just moved RHS there. It will, to RHS it will become 1 by sine theta plus 1 by sine theta. So let's solve LHS now separately and RHS separately. So again, what we'll take LCM because you know that the denominators are again in the form of A minus B, A plus B. So cosec square theta minus cot square theta. Again, A plus B into A minus B is A square minus B square. And in numerator, cross multiply. That is cosec theta plus cot theta plus cosec theta minus cot theta. Can we cut something here? Yes, cot theta, cot theta. So we are left with 2 cosec theta. And in denominator, what is cosec square theta minus cot square theta? It's 1. Just see in RHS, what we get in RHS, it's sine theta and 1 plus 1 is 2. And what is 2 by sine theta? It's 2 cosec theta. So again, it's equal. Hence proved. Let's move to next topic. convert everything in sine theta and cos theta. When you will do that, when you feel that you can't use your trigonometric identities, or you can't take LCM, or you can't do rationalization, at that moment you have only one option, that convert everything in sine and cos. So for that you can use your quotient as well as reciprocal identities that you already know. So let's move to question number 1. Here, first what I can do, I can just multiply this using distributive property, or you can directly put the value. It's up to you. I'm just multiplying that. Sine theta plus, what is sine into tan? That is sine into sine by cos. You can write sine square by cos theta plus cos into 1, that is cos theta, plus cos into cot. Now cot is cos by sine. So you can write cos square theta by sine theta. Did you realize something here? That if you will pair these two, this and this, what you will get? Just see, sine theta by 1 plus cos square theta by sine theta, and remaining two write together, sine square theta cos theta plus cos theta by 1. Why we did this? Because now when we take the LCM and if we do cross multiplication, it becomes identity, that is sine square theta plus cos square theta. Yes. And similarly there, when you will take LCM and do cross multiplication, it becomes identity. Now what is sine square plus cos square? It's 1. What is sine square plus cos square? It's 1. What you can write? 1 by sine theta plus 1 by cos theta. Now what is 1 by sine theta? Take the rest, see the reciprocal of sine, it's cosec, and see the reciprocal of cos, it's sec. Hence proved. Cosec plus sec and sec plus cosec, both are same. Let's move to question number 2. In question number 2, again, you will write tan as sine by cos and cot as cos by sine. And similarly here, cos by sine and sine by cos. Just solve this. By taking the LCM, what you will get? Sine by cos. And here, sine theta is LCM. For numerator, we will do cross multiplication. That is sine theta minus cos theta. And here, sine theta, and that is cos theta. And here you can write cos theta minus sine theta. Yes. Now you have to just take the reciprocal, because it will go in numerator. Reciprocal, similarly it will go in numerator. Reciprocal. So it becomes, you will multiply the extreme ones, sine and sine. Sine square theta by cos theta into sine theta minus cos theta, plus again multiply the extremes, cos square theta by sine theta into cos theta minus sine theta. It's the NCRT question. Now if you take the LCM of these two, see, cos theta one time, sine theta one time, but you know that the LCM of a minus b and b minus a, you can take a minus b and minus sign outside. We can take here, we can take LCM as anyone, like sine theta minus cos theta. So what I will do here, what we don't have sine, so I will multiply with sine numerator, that is sine cube. Here what we don't have, we minus sign. We always change this sign. If you're writing this as it is, so you will change sign of this second one. Now again, we don't have cos, we'll write cos cube theta. Now what is a cube minus b cube? That is a minus b sine theta minus cos theta into a square, that is sine square theta plus b square cos square theta. If here it's minus, then at last you write plus ab, that is sin theta cos theta. Now divided by cos theta sin theta into sin theta minus cos theta. Now you can cut this. You are left with, what is sin square plus cos square? It's 1. So you are left with 1 plus sin theta cos theta by cos theta sin theta. So I'm giving cos theta sin theta to both. Cos theta sin theta, and here also cos theta sin theta. So what it becomes? It becomes 1. And this 1 by cos is sec theta, and 1 by cos sec. So hence proved 1 plus sec plus cos sec. I think it's clear to everyone. This is cos sec. Okay, let's move to next question. Question number 3. Now you can do this question on your own. It's very easy, exactly like what I did in question number 2. Just write tan as sine by cos, and cosec as 1 by sine, and sec as 1 by cos. This is homework for you. Now let's do question number 4. In question number 4, what you will do? We need 2 here. Okay, so let's convert everything again in sine cos. What is cot? It's cos by sine. Cosec 1 by sine into tan is sine by cos, and sec is 1 by cos. Yes, take the LCM. Here the LCM is sine A. Here I have to multiply this with sine because LCM is sine, and rest I have to copy as it is, cos A minus 1. Similarly here we'll take the LCM cos A. Here I will multiply it with cos A because denominator is 1, and rest I will copy as it is. Now just see carefully. Can I use any identity here? Let's think. If you will take this as A and this is B, A minus B, A plus B. So I can write A square minus B square, that is sin A plus cos A square minus 1 square, and in denominator sin into cos A. Yes, now just use A plus B whole square, that is sin square plus cos square plus 2 sin A cos A minus 1 by sin A cos A. This is 1, so you can cut 1 and minus 1. So you are left with 2 sin A cos A by sin A cos A. So you can cut sin A cos A, sin A cos A, and you are left with 2. That's your answer. Answer is 2. That is RHS. Let's move to next question. Question number 5. You will write sec as 1 by cos A. Here again 1 by cos A. Take the LCM. That is cos A plus 1 by cos A. And here 1 by cos A. We can cut cos A and cos A. So we are left with cos A plus 1. Now let's solve your RHS. This is your LHS. Now let's solve RHS. For RHS, just think sine square A. What is sine square A? It is 1 minus cos square A. Because we don't want sine now, we want this cos A plus 1. So 1 minus cos square A, and in denominator it's 1 minus cos A. Now what is A square minus B square? It's 1 plus cos A plus B, and A minus B. Now just cut this 1 minus cos A, and you are left with 1 plus cos A. And that's it. They are equal. Let's move to next topic. Most important question, and it's Type. Under this topic, I have written three questions for you. Just observe this type. Here, in numerator and denominator, we have three terms and all are same. Cot theta, cosec theta and 1. What is different? Their sign. So in this type of question, you have to just see the 1 in numerator. Now we have to replace this 1 with the help of identity that involves cot and cosec. We know that there is one identity. Cosec square theta minus cot square theta is 1. Yes, we know that. So let's replace that. But in this question, never touch your denominator. That you have to write as it is. So cot theta plus cosec theta minus, in bracket you will write cosec square theta minus cot square theta. And denominator you will copy as it is. That is cot theta minus cosec theta plus 1. Now what I will do, I will just use one identity for this bracket. We know a square minus b square. Here it's minus a square minus b square is a minus b into a plus b. So I will use that cot theta plus cosec theta minus, just write this cosec theta minus cot theta into cosec theta plus cot theta. Denominator is again same. Cot theta minus cosec theta plus 1. Now, did you observe something here? Yes. Just see this one and this one. Both are same. So can I take this common? Yes, you can take this common. Just write cot theta plus cosec theta outside. And in bracket, what we are left with? If you have taken everything common, that means we are left with 1. Don't write 0. Minus, now after minus we have cosec theta minus cot theta, but in bracket. You see this bracket carefully, it's inside the bracket. And in denominator, you will copy the same thing, cot theta minus cosec theta plus 1. Now, did you observe something here? Whenever we have a minus sign outside, what we have to do? We have to remove the bracket and change the sign of both the terms inside the bracket. So what will be my next step? I am doing the changes here only. So this, if I will remove this bracket, it becomes minus, but this becomes plus because you have to change sign of both. Plus becomes minus and minus becomes plus. Now, you can cut this and this, it's same. So you are left with cot theta plus cosec theta and hence proof because that is your RHS. Now I'm giving you hint for question number 2. That's your homework because it's exactly same like question number 1. But in this case, you have to replace this one with secant square minus tan square theta. And then again you will write sec theta plus tan theta into sec theta minus tan theta and then you will take common and you will get your answer. Let's move to next question. Here, when this question comes in terms of sine and cos, then you have to be careful because here we can't replace 1 by a square minus b square. As you know that here 1 is sine square theta plus cos square theta. We can only do that directly when it's here it's minus, but in this case it's positive. I can't use identity then. So what I will do here so I can't replace directly. So in this case, first thing what you have to do is just think what is sec theta. It's 1 by cos theta. And what is tan theta? It's sine theta by cos theta. That means in denominator we are getting cos. So let's divide numerator and denominator by cos. When you will divide numerator by cos, what will get? Sine by cos, just two mentally, tan. Cos by cos, 1. And 1 by cos, secant. Similarly in the denominator, cos, sine by cos, tan. Cos by cos, 1. And 1 by cos, secant. Did you realize something? See carefully. This is same portion like this, secant and tan terms. So what you will do now, you will simply replace your one. I'm writing tan and secant first and then my minus 1. In denominator, no need to worry. You have to just leave as it is. Now what you will do, as I've given you hint here, you will replace this one by secant square theta minus tan square theta. Again, I'm repeating, secant will always come first if you want 1. Yes. Now I can break this as sec theta minus tan theta, sec theta plus tan theta. So you will take tan theta plus secant theta common. Here you have taken everything common, you are left with 1 and minus. Because here you have taken tan theta, secant theta common, so you're left with secant theta minus tan theta. So you will change the sign, that is minus secant theta plus tan theta. And it will get cut. And here's the answer. Suppose here, although I got this answer, but if it's not this, then you will further simplify tan theta plus secant theta. And now let's move to last topic, extra questions. In extra question, just see first two carefully. Whenever these are same, what you have to prove and what is given. Just coefficients interchange. Here it's 1, here it's 1. Here though it's, if it interchange also it doesn't matter, but the sign is different. See here 3 5, here it's 5 3, and the sign are different. It's plus and it's minus. So in this type of question, there is simple approach that takes square both the sides here and here. So let's start. Cos square theta plus sin square theta plus 2 sin theta cos theta is equal to 1 square is 1. Now what is this? This is also 1. Yes. So if you transpose this 1 minus 1, it becomes 0. So 2 sin theta cos theta is 0. Just stop here. Now come to RHS. Again, as I told you, square both the sides. So you have to prove this. So just leave this. You will take square of this. What is square of this? Cos square theta plus sin square theta minus 2 cos theta sin theta. Yes. You put the value that you have used. What is cos square plus sin square? It's 1. 1 minus 2 sin theta cos theta, and that is 0. 1 minus 0 is 0. That is 1. Now, square is 1. That means if you want to find square is 1. If you want to find cos theta minus sin theta, what is this? Root plus minus 1. And that's it. You have proved. So always take square of this and square of what you have to find. Then you will get this right side. Let's move to question 2. Again, square both the sides. That is 9 sin square theta plus 25 cos square theta plus 3 into 5 is 15, 15 into 30, 30 sin theta cos theta. But in this case, when we have only 1, then though there is no problem. But when we have numbers, it can be anything. Then just say first thing is taking square both the sides. Second thing, because you have to interchange the coefficient, second thing is replace sine square by 1 minus cos square and cos square by 1 minus sine square. Whatever I'm telling you, this will hold for all the types of questions where your sine and cos are same, but just the coefficient are interchanged and middle one sign gets changed. So what you will do, first taking square both the sides. Second, replace your sine square by 1 minus cos square and cos square by 1 minus sine square. This is the second step. Now just write this equal to 25 equal to 25. Let's solve this. What will get? 9 minus 9 cos square theta plus 25 minus 25 sin square theta plus 30 sin theta cos theta equal to 25. Can we cut something here? Yes, 25 and 25 becomes 0. Now, did you observe something here? It's minus 9 cos square theta minus 25 sin square theta. And here, if we have to prove this, that means before this, what we need? If it's plus minus, that means we need this here. if we prove this, then this implies this. That means we need 5 sine theta minus 3 cos theta whole square. But here the problem is that minus a square and b square can't be negative. So we'll take minus sign common. We'll write 9 cos square theta plus 25 sine square theta minus 30 sine theta cos theta is equal to 0. Now, if you will transpose this whole to that side or 9 to that side, it becomes minus 9 and minus minus you cancel. And what is this? What is this? This is nothing but 5 sine 5 sine theta minus 3 cos theta whole square. So you have proof that this is 9. That means this is plus minus 3. I think that this type of question is clear to you. Let's move to third question. In third question, it's given that your x sine theta is equal to y cos theta. So what we'll do here, just break this x sine theta into sine square theta plus y cos cube theta is equal to sine theta cos theta. Yes. Now, first I'm putting my x sine theta as y cos theta. Y cos theta sine square theta plus y cos cube theta is equal to sine theta cos theta. Now can we do something here? Just think. We can take y cos theta common. So we are left with sine square theta plus cos square theta. And here sine theta cos theta. If you realize something here, it's 1. So that means y cos theta is equal to sine theta cos theta. Now let's get cos theta. So y is sine theta. Similarly, now I will break this time y cos theta. I will write y cos theta into cos square theta. Yes, similarly I will do that. Like I did in first, I replace x sine theta as y cos theta. Now I will do reverse. Okay, so now you will replace this y cos theta by x sine theta. Now I can take common something. Yes, you can take common x sine theta. You will left with sine square theta plus cos square theta. That is sine theta cos theta. Now this is 1. Sine theta you can cut. So your x is cos theta. Now you know the values of x and y. You know the values of y sine theta and x is cos theta. They are saying what is the square of x square plus y square? Sum of square. So you will write that is cos square theta plus sine square theta. And what is that? It's 1 using identity. So answer is 1. We have proved that. Now let's move to last question. So here we'll do regrouping. That means first and third and second and fourth. So me write that first. 2 sine A cos A minus 2 sine A. And here minus cos A plus 1 equal to 0. Now I can take 2 sine A common. What I'm left with? Cos A minus 1. And here if I want the bracket same, so what I will take outside? I will take minus 1 outside. Now outer ones together in one bracket and common one in one bracket. We know factorization of four terms. We did that in 8th class also. Now if product is 0, that means either first is 0 or second is 0. First you will equate first as 0. So it will give you sine A as half. And if you will equate second as 0, you will get cos A as 1. Now think, when your sine A is half at 30 degree and when your cos A is 1 at 0 degree. So possibilities are 0 degree and 30 degree. Do all these questions sincerely and good marks in trigonometry are guaranteed. If you find this video helpful, don't forget to like, share and subscribe to my channel Mathify with Meenakshi. Thank you everyone.